Hey guys, and welcome to 3.6, the last class of chapter 3, or the last lesson of chapter 3. We did 3.6 completely on the calculator. I taught you how to use a calculator to solve a matrix, and that is just because I don't want to burden you with a huge amount of doing stuff that you will never do again, okay? It will take you a lot of time to solve them the right way. If you get one single one wrong, you get everything else wrong. So we figured we're just going to use our friend in here. Okay. 3.6 deals with solving system of linear equations in 3 variables, which means we have an x, we have a y, and we have a z. Now, we're on example 1 on page 178, and it says solve this system. The first thing I want you to remember is we talked in class. We're going to transpose this into a matrix. You've heard of matrices, believe it or not, chapter 4 is all about matrices. I'm just starting you right now, okay? We're going to make it into something that is in between, I don't even know what you call this, some sort of grouping symbols that's going to have rows, and it's going to have columns that are completely aligned. Before we do anything else, we said in class, if you find any variable that does not have a coefficient, like this negative y, the first thing you want to do is put that 1 in front of it. And here's why. We're going to write just the coefficients in your first row. Remember, we said these are rows, these are columns. If you look at this, 1, 2, 3, I know I'm going to have 3 rows. And if I look at this and I go x, y, z, and the constant, I have 4 columns, right? And now we're going to go then by rows, and we're just going to write numbers, not the variables. So for my first row, I have 3, 2, 4, 11. I'm done with the first equation. I'm moving to the second one on the second row. We keep them under the columns. 2, negative 1. That's why I told you write a 1 there so you know there's a number there. 3, 4, and for my third and final row, 5, negative 3, 5, negative 1. I now have my matrix. Now, let's remember we did this in class. How do we do this on a calculator? We are going to go with second matrix, and it's going to bring you right here. All of your instruction on board, I'm going to try to keep the calculator here. And we're going to go over to edit. That's where we want to go, okay? And then we're going to hit enter. And there's my first matrix. Your first row is asking you to define it. How many rows, how many columns? First number your rows, second number your columns. Let's look on the board. How many rows do I have? 1, 2, 3. So I'm going to hit 3, and I'm going to say enter. It's going to move it to the columns. Let me number my columns. 1, 2, 3, 4. I can now put 4 and hit enter. I am now inside my matrix. And now we're going to go, and that's why I wrote in here, input your values by rows. We're going to go 3, enter, 2, enter, 4, enter, 11, enter. And you're going to notice once you put the 11, it's going to move back to the second row. We're going to start second row. 2, enter, negative 1, enter, 3, enter, 4, enter. Please remember for your negatives to use your negative, not your minus. You're going to get an error. For your third row, 5, enter, negative 3, enter, 5, enter, negative 1, enter. Our rows and columns are now all in. I have input all of my matrix, right? We said at the moment we do this, we're going to go ahead and quit. Second, quit right next to each other. And we're back out. We're going right back into the second matrix. And now I'm going to move over to, oh, it's called math, not calc. I'm so sorry. Math. Okay, let me remove this from here. I don't want you to be confused when you watch the video. This is math. I really was sure it's called. And here we said we go down until we get to letter B. You see we have numbers. When the numbers are done, we're going to get to letters. Or we're looking for R, R, E, F. There is an R, E, F. We don't care about that. We need a double R. But the easiest way to be is you go down until you reach B. 0, A, and there's B, right? B has an RRF, and we hit enter. We're right here. We're going to go back to second matrix and hit enter because we're really dealing with matrix A. And now I hit enter again. We get an identical matrix, which we don't care about, you know. But what we do care about is the last numbers of the last column, because your first number in that column, that -3, is your x, the 2 is your y, the 4 is your z. So the calculator solved for you. X is -3, y is 2, and z is 4. If you check your book, that is the answer. So that's how we did this. Let's do another one. We're going to play with 3 of these or 4 of these and see how we do. I'm going to erase just this right here because I need the space to transpose our matrix. I'm going to erase our system of equations. Our second one is x plus y plus z is 2. X plus y plus z equals 2. 3x, 3y, 3z equals 14. 3x plus 3y plus 3z equals, did I say 13? Did I say that? 14. And then the last one would be x minus 2y plus z equals 4. X minus 2y plus, what did I say? Plus z equals 4. Okay, we got this. We're going to go the steps. Here goes my first row. Remember, these don't have coefficients. Put a 1 in front of them. This becomes 1, 1, 1, 2, 3, 3, 3, 14, 1, -2, 1, 4. We're going to go back into our steps. I'm not going to do this in here. We're going to go second matrix over to edit. We like this. It's already set up. It's 3 by 4. We just hit enter, enter, and now we have to put our matrix. If it helps you better, type again 3, enter, 4, enter, and you know what it is. So I go 1, 1, 1, 2. It moves me to the second row. 3, 3, 3, 14, and then 1, -2, 1, 4. My matrix is put in. I'm going to go second quit. Back to second and matrix. I'm going to go over to math, go all the way down to B or RRF. Second matrix, and A is selected, so I just hit enter. I'm right there and I hit enter. And I want you to notice, what are we getting? We are not getting what we're supposed to get, are we? I'm trying to look at this and see. Did I put in the wrong numbers? I think I messed up my numbers. One, two, three, three. Let me look at my last column because I know this is correct. 2, 14, 4. Oh, yes, never mind. I did get what I'm supposed to get. I'm so sorry. I messed up. Second quit. Do you remember how I told you that in order to get a solution, right down there, you should have a 1? It should be 1, 1, 1. It threw me off for a second. That does not have a 1 there, right? We do not have the identity matrix in there. As soon as you're missing that, this means no solution. Right? You see how this line should have been in here, this would have been in there. They're messed up. Unless you get your first one in a row like this, 1, 1, 1, because this is 0, not a 1, that means this has no solution. Right? We said that in class. I don't know why it threw me off, but it did throw me off really, really, really bad. Okay? Let's look at another example and see what we do when we have different options with different stuff. Here's my next one. 1x plus 1y plus 1z equals 2. I have to write this the right way. 1x plus 1y minus 1z equals 2. And 2x plus 2y plus 1z equals 4. Look at this. Did I get them right? Yes. Here's my thing. Let's get our first row. 1, 1, 1, 2 for my second row. 1, 1, -1, 2, 2, 2, 1, 4. Back to my calculator. Second matrix, all over to edit, enter, 3, enter, 4, enter. Let's go. 1, 1, 1, 2, 1, 1, -1, 2, 2, 2, 1, 4. Second quit. Second matrix, we're going to math. We're going to go all the way to B. And then again, second matrix, enter. We hit enter. And I want you to notice what happens in this case. Do you see how we get, not only do we not have an identity matrix, but we have a 2 over there. This is 1, 1, 2. 1, 1, 2, 1, 1, and then a 2 over there and 2 over there. As soon as that is off by that 1, this means it has multiple solutions. Okay? That means that is a system with multiple solutions. You could have all kind of solutions for this one, which basically means it's infinite solutions. We can get as many as we want. They're all numbers. We'll check all 3 equations. Okay? This is how we do the using a calculator. I have not given you a lot that have no solution in your homework on purpose, or multiple solutions, so I will not confuse you. I'm going to still leave those there. We're going to look at the word problem that we have over there. It says, use a system of equations to model the information in a newspaper article. Solve the system to find how many swimmers finished in each place. Why is this important? Because for the first time, we are going to be missing a variable in one of the equations, okay? And maybe I should do one of those with you before I even jump into something else. Do you have something like that for homework? I'm trying to remember if I assigned you one of those for homework or not. I don't think so. I think I kept it. But let's look at the little article in the paper. I will let you go ahead and pause and read it if you need to. But here's what we know about the verbal model. The first place finisher plus the second place finisher plus the third place finisher gives you how many people placed, right? So the first place is an X plus Y for the second place plus Z for the third place. Gives me how many people were in the race, which is 24. I'm going to put a 1 in front of them. I should have done that from the beginning. The second one, it says this. At first place finish scores 5 points. So you get points per first place times first place finishers, or 5x, plus if you get a second place, you get 3 points, so it's going to be 3y, plus if you finish third place, you just get 1 point, 1z. The total of points in this case, we get 56. The last piece of information that you get in here, they tell you that you get as many third placers as first place and second place together. So my third equation is 1x plus 1y equals 1z, right? That's basically how much I have this set up. In order to get this in the equation, I need to move my 1z on the other side. Minus 1z, and this becomes just 0, correct? Now, had we do it the way the book teaches you, your z is already defined. You would have plugged it in here, get 2 equations, and then from 2 equations, get your x and your y out, and then so forth. We just move it over here because we want our values in. Let's go ahead and do our matrix. 1, 1, 1, 24 for my first row. 5, 3, 1, 56. 1, 1, negative 1, 0 are my last thing. We're going to go ahead and plug it in here and see if we get the right answers or not. The book will tell us. Second matrix, all over to edit. You can just do enter, enter, because it's a 3x4. It's always going to be a 3x4. Let's go ahead and do 1, 1, 1, 24. My first row is done. 5, 3, oh, I put the wrong number in. 1, 56 points. And then my third row is 1, 1, negative 1, and 0. I actually need to plug in that in. So your last column should look like this. Okay? Second quit. I'm going to go back to second matrix over the math. I'm going to go all the way down to B. As soon as I hit B, it kicks me right out here. So I'm going to go back again to second matrix. I just need my first matrix right there, so I'm going to hit enter. And then hit enter again. Look what you get. You get 4 people for first place. And then you get 8 people for second place. And then you get 12 people for third place. If we need to check it, my first one says that when I add them together, I should get 24. 12 plus 12, 24. 20 plus 24, 40, 20 plus, am I doing this right? 20 plus 24. Why am I struggling in here? Right? Yeah, X, Y, Z, that's correct. Oh my gosh. Yes, 20 plus 24 gives us 44. Plus 12, 1 times 12, 12, 56. And if I go x plus y, 12 minus 12 gives me 0. So this is how we solve problems using a matrix. That's about all of your homework, and that's about all of chapter 3. Happy homework.